Greetings everyone and welcome to my AI training lab. In my previous videos we trained this tralala AI to run for me, to eat me. We removed limbs from this exact robot in real time to observe its behavior and to make some fun. And we tried to teach this hot anime girl to stand, and we suffered a catastrophic failure. Those were cool experiments. This shark, this robot, this anime girl, they gave us a lot of experience, but today I have something special for you. Stay tuned. Ladies and gentlemen, I present to you the Robotic Ant, constructed from modular components and ready to charge onto the battlefield with reinforcement learning. In this video I decided to train this ant to walk, but here's our first problem. This ant is too small for effective handling by Unity's physics engine, so we need to make it bigger. Yo, I said something bigger, not gigantic. Give me something a little bit smaller, please. Now, this ant is suitable for our needs. We will start our journey with it, adding complexity to its body during training by giving it more legs and body parts. But the most interesting part is that we will need to adjust the neural network that runs our ant. So we will increase its brain size to enable learning more complex locomotion behaviors by enhancing its neural network's complexity. What? Do these terms sound too complex to you? Let me explain some technical details. This is neural network, a simplified artificial copy of the most complex object in the whole universe, the human brain. This is precisely what will give our ant the desire to live, learn, and explore the virtual world created by me. In this video we will progressively train different ants using larger neural networks, starting with a brain of a primitive single-celled organisms like bacteria, all the way to the brain of an octopus. Yeah, it's fine now, but adjust its grip. Thank you. Now I will explain in details how our ant will train and move. Just give me a moment. This neural network has indeed heavy computational power. To train neural network we give it inputs which it then processes inside to generate outputs, the actions. In our case, the inputs are observations of an ant's body. We will provide the model with the local rotation, position, and velocity of each joint in the ant's body. This ant has 10 joints. Each joint has 20 parameters. Total amount of parameters is 200. Along with orientation, we will provide the direction towards the target the ant aims to reach. The outputs of this model, the outputs are actions the ant will perform. The model will output values ranging from -1 to 1. which we will convert into the target rotation for the ant's joints. This is example of the ant's movement we will receive. And then the Unity's physics engine handles the rest for us. Inputs and outputs have constant size. This means we cannot change it later. This is unfortunate, so we need to know from the outset which parameters are required. If we want to change something in our ant's configuration, we cannot simply add a parameter. We will have to retrain it from scratch. Now, the middle section of our neural network is a black box of variable size where processing occurs. The larger the middle section is, the larger the IQ of our AI. But we are missing the most important thing. The most important thing in the whole training process is the reward. Rewards is run everything in our training process. The reward is the only thing that enforces our AI to explore and learn. And you might ask, how exactly will this work? How can we make these untrained, naive ants learn and evolve? The answer is, we will give it a reward every frame if the average speed of the ant's body is directed toward its target. This is that simple. The beauty of reinforcement learning is that the AI learns everything by itself. We just need to point it in the right direction. We are now ready for the first stage of training. Well, the behavior of our AI is indeed questionable. We could blame the physics engine, but I assure you that Unity has a worthy NVIDIA physics engine with pretty good gravity, bounciness and friction simulation. All necessary parameters enabled and adjusted in this simulation. I'm pretty sure that our problem lies elsewhere. As you can see right here, our ant consumes 200 observations and generates 13 actions, which is quite a lot for this small ant. Stuff all of that into an insanely small brain of a bacteria leads to unpleasant consequences. Our AI needs to improve, it needs to evolve. Sorry, little one, you are too single-celled for this world. This gun is almost perfect now. Oh, are we live? The first experiment showed that besides a small brain, the AI also had other parameters that needed to be calibrated. And Unity has quite a lot of these parameters. One of those parameters is the decision period, which tells our system how frequently our ant must perform actions. This parameter was set to 1, meaning one action every frame, but with this high frequency our system is struggling to adapt. That and unfine-tuned parameters of joints, such as maximum force and values of damper and spring, resulted in quite unsatisfactory movement. Moving to the next experiment, we will adjust these parameters to bring more smoothness to our AI creature. But we will try to fix all of these problems in our next test subject. Ladies and gentlemen, meet our second ant with a larger number of legs, with thicker ass, and of course, with a bigger brain. Let's see how this new AI will perform. The second training cycle was indeed successful. Our robotic ant now exhibits locomotion similar to the real one. And you know what? I'm even thinking that this time I won't have to use my gun. This subject has effectively learned to control its limbs and is developing considerable speed. But the mad scientist inside me is convinced that evolution can still continue. We still have some room for improvements. Let's increase the size of its brain, and with a bigger brain we can augment its body one more time. Let's get it done. Let the creation begin. First, we will remove all obsolete parts. We will add a head with greater capacity and intimidation. We will add an additional torso. And one more. Now it is ready. Rise, my creation, and show everyone what you are capable of. Bravo, bravissimo, hooray to everyone. Great job, dear viewers. I believe we've achieved a magnificent result together and pushed the capabilities of our AI ant to the limit. It's been an exciting journey and I'm glad you are here with me. A huge thanks to everyone for watching, I really appreciate it. Please hit the like button below, subscribe to the channel and let me know in the comments which creation I should train next. And I see you guys in another video. See you soon. Huh? What was that? Oh no, oh my god, I think we made this ant too smart. It created its own army of robotic ants and is summoning it here right now. Workers, stop him! Oh God, what have you done? Help me! Workers, what are you staring at? Hurry up and help me, please! Oh. Holy crap, there are too many of them! I don't think I can hold them back for long! No! Farewell, friend!